Hello students, welcome to a series of mathematics programs for grade 10 and grade 11. The topic for today is matrices. This is the fourth lesson on matrices. In fact, it is the fourth and final lesson on matrices. You will remember that in the previous lessons, you had learned what is a matrix, how to display information in the form of a matrix, how to add and subtract where appropriate two matrices, how to calculate the product of a matrix and a scalar, how to find the product of two matrices, how to calculate the determinant and inverse of a non-singular matrix A, and finally, how to solve matrix equations. In today's lesson, you will learn how to use the algebra of 2x2 matrices, including the zero and identity 2x2 matrices, how to solve matrix equations. Here we will look at matrix equations involving the product of two matrices, and finally, how to solve simultaneous equations using the matrix method. Now, remember in the previous lessons, we had learned what is an identity matrix. So an identity matrix is a square matrix where all the elements will be zero except the elements in the leading diagonal. In the leading diagonal, all the elements will be 1. Here, we are going to consider only 2x2 identity matrix. So this is the identity matrix, the 2x2 identity matrix. You will have 1, 0, 0, 1. Now, suppose you have matrix A, a 2x2 matrix again, with elements A, B, C, and D. If I want to find the product AI, I need to take matrix A and multiply by matrix I. So, as we have learned earlier, I will have to take first row, multiply by first column, then first row multiplied by second column. Next, second row multiplied by first column, and finally second row multiplied by second column. So multiplying all these, I will have A times 1 plus B times 0. Next, A times 0 plus B times 1, which I put here. Then C times 1 plus D times 0, which I write here. And finally, C times 0 plus D times 1, which I put here. So simplifying, B times 0 will give me 0. A times 1 is A, so I get A. Similarly, I will have B, C, and D. And you can see that the product AI is in fact equal to matrix A. So AI is equal to A. Now, suppose I need to find I times A, the product of IA. So this means I take matrix I multiplied by matrix A. So again, I will have to multiply first row by first column, first row by second column, second row by first column, and second row by second column. I'm sure by now you know how to multiply matrices. So multiplying these and simplifying will give me A, B, C, D, which is again a matrix A. So what have we observed? Here, we have seen that A times I is equal to A, and I times A is equal to A. So what you need to understand is that any matrix, any 2x2 matrix, when you multiply it by the identity matrix, you get the matrix itself. Similarly, the identity matrix times the 2x2 matrix, any 2x2 matrix, will give you this 2x2 matrix. This is a very important result. Now consider the matrix A with again elements A, B, C, D. You will remember that in the previous lesson, you had learned how to find the inverse of the matrix A. So the inverse is given by 1 over determinant of A, where determinant of A is A times D minus B times C times the adjoint. Remember, these two will swap places and these two will change sign. So the inverse of matrix A given by A inverse is here. Now, suppose I want to find the product of A and A inverse. So here is matrix A multiplied by A inverse. Now this is a number, this is a scalar. 1 over a number will still be a number or a scalar. So I can put it in front here and I multiply these two matrices, A, B, C, D times D minus B minus C, A. So again, you multiply row by column, just as we have done before. This will give me 1 over AD minus BC. And these two will cancel. I will get 0 for these two entries. So I have AD minus BC, 0, 0, AD minus BC. Now, AD minus BC times 1 over AD minus BC will give me 1. Here we get 0, 0, 1. So A times A inverse has given us I, the identity matrix. Now, if I want to find A inverse times A, so this is A inverse multiplied by A. So multiplying these two matrices will give me 1 over AD minus BC into AD minus BC. Here I will get BD minus BD, which will be 0, minus AC plus AC, which will be 0, minus BC plus AD. So this I can rewrite as AD minus BC. And multiplying these elements by 1 over AD minus BC, I will get 1, 0, 0, 1, which is the identity matrix. So A times A inverse gives me the identity matrix. A inverse times A will also give me the identity matrix. This is the second important result which you need to remember. Now let us look at this example. Find X given part A, AX equal to B, part B, XA equal to B, where A and B have been given here. So part A, AX equal to B. I need to find the matrix X. What I'm going to do here, I'm going to pre-multiply. Pre-multiply means you multiply in front by A inverse on both sides. I pre-multiply by A inverse on both sides. So you have A inverse times AX equal to A inverse times B. Now, we have just learned that A inverse times A is I. So I get I times X equal to A inverse B. We have also learned that I times A was equal to A. So here I times X will give me X. Therefore, X is equal to A inverse B. So I had to find the matrix X. And we have seen that X is equal to A inverse times B. Therefore, I need to find matrix, the inverse of matrix A. Remember how to find the inverse? First, I need to find the determinant. So the determinant of A will be 1 times 4 minus 2 times 3, which is negative 2. Then I need to find the adjoint of matrix A. So these two will interchange places and these two will change sign. So I get my adjoint of A. A inverse will be 1 over determinant times adjoint of A. So here is A inverse. Now, X is equal to A inverse times B. A inverse we have just found. Here's matrix B, and I need to multiply these two matrices. So I will have -2 times -2 plus 1 times 5 here. -2 times 4 plus 1 times -1, which I put here. Then 3/2 times -2 plus -½ times 5, which I put here. And finally, 3/2 times 4 plus -½ times -1, which I place here. Simplifying, I will get my matrix X as 9, -9, -11/2, and 13/2. Now for part B. I have X A equal to B. So here I'm going to post multiply by A inverse on both sides. Post multiply means you multiply at the back. So I have X A. I multiply by A inverse here on both sides. Now A times A inverse is I. So I get X I equal to B A inverse. Remember, I times A equal to A times I equal to A. So here I will get X equal to B A inverse. And A inverse we had found in part A. So X will be equal to B A inverse. So you have B here times A inverse, and simplifying will give you X equal to 10, -4, -23/2, and 11/2. We have looked at two different cases. One where we have to pre-multiply and one where we have to post-multiply. So you need to be careful. Now we're going to look at solving simultaneous equations using matrices. You will remember that in earlier grades, you have learned how to solve simultaneous equations using the substitution method, the elimination method, and the graphical method. Now we are going to look at solving simultaneous equations using what we call the matrix method. So consider this example. X plus 2y equal to 5 and 3x minus y equal to 8. The first thing that you need to do is to ensure that x is written under x and y under y. Now, we are going to solve these two equations using matrices. So in matrix form, I'm going to consider the coefficients. Here, the coefficient is 1 and 2. So I write 1, 2. Here we have 3 and -1. Be careful, this is not 1, this is -1. So my unknowns are x and y equal to 5, 8. You can check if you multiply, you're going to have 1 times x plus 2 times y equal to 5, 3 times x plus -1 times y equal to 8, and you're going to obtain the original equations. So what we have done, we have converted these two equations into matrix form. So now I need to find x and y. Let A be equal to this matrix, 1, 2, 3, -1. This is going to be matrix X, and this is going to be matrix B. So this means that I have AX equal to B. AX equal to B. So remember in the previous example, we had to pre-multiply by A inverse on both sides because I need to find X. So pre-multiply by A inverse on both sides. You have this line. Now A inverse times A is I. So I have IX equal to A inverse B. Now IX is same as X. So X equal to A inverse B. Okay. So A is 1, 2, 3 minus 1, X is XY, and B is 5, 8. So first I need to find A inverse. To find A inverse, I need to find the determinant. I'm sure now you can easily find A inverse. So I find the determinant, which is minus 1, minus 6, minus 7. I find the adjoint, and A inverse will be 1 over determinant times the adjoint. So X equal to A inverse times B. So here is A inverse times B. B is 5, 8. I simplify. I multiply these two matrices. I get X equal to 1 over minus 7 into minus 21 minus 7. So multiplying these, I get 3, 1. Now X was, capital matrix X was X, Y. So this means that X equal to 3 and Y equal to 1. Let us now consider a second example. Solve a pair of simultaneous equations using the matrix method. So first, like I've said in the previous example, ensure that X is under X, Y is under Y, because we're going to consider the coefficients. So writing this in matrix form, I will have 2, 3, the two coefficients, 1 minus 4, my unknowns are X, Y, equal to 117. So this will be A, this will be X, and this will be B. So I have AX equal to B. I will have to pre-multiply by A inverse on both sides. So A inverse A is I, and I times X is X. So X will be A inverse B. So I need to find A inverse. Remember how to find A inverse? We need to find the determinant. So minus 8 minus 3, which is minus 11. Then I need to find the adjoint of matrix A, and finally A inverse. Now X is A inverse times B. So I multiply these two matrices, and then I multiply the resulting matrix by 1 over negative 11. So I get 5, negative 3. Therefore, X will be equal to 5 and Y will be equal to negative 3. You now have some questions to practice on what you have just learned. That is solving matrix equations and solving simultaneous equations using the matrix method. You also have some interesting links for you to get additional information on how to solve simultaneous equations using matrices, as well as how to solve matrix equations. So students, in this lesson, we have learned together how to use the algebra of 2 by 2 matrices, including the zero and identity 2 by 2 matrices. We have learned how to solve matrix equations, as well as how to solve simultaneous equations using the matrix method. I hope you have understood the different concepts found in the chapter matrices. I would advise you to attempt the questions found in your textbook, as well as the questions found in the different videos. These will help you to better understand the different concepts. Remember, practice makes perfect. So you need to practice these questions. You can also ask for the help of your teacher, your parents, or even your friends in case you have any problem. So this is the end of the lesson on matrices. Until we meet again, it's goodbye from me. Thank you for your attention.